This is, I can't remember if it's part 3 or part 4, honestly, but this is should be the last set of notes for chapter 35 on the nervous system. And as you can see, we're on slide 23, which is the brain. The largest part of the brain that we talk about being divided into left and right hemispheres is called the cerebrum. And then, and you see a picture of it here. Here we go. Okay, and it communicates with and coordinates the activities of the other parts of the brain. Um, and then the divider in the middle, or the fissure, this little section here, is called the longitudinal fissure, and it divides the cerebrum into left and right hemispheres. This is a cross section. Well, actually, this is a frontal section through the brain, is what I would call it. It's a cross section, but specifically it's a frontal, or I am so sorry. It is not. It is a sagittal section. It's a sagittal section through the brain. Sagittal section would divide the body into equal left and right halves. So this is a sagittal section through the brain. This, of course, this whole area is the cerebrum. And then you can see the meninges, um, which we talked about, the pia mater, the arachnoid mater, and the dura mater in order. Pia, arachnoid, dura. Um, okay, and then the corpus callosum, the pituitary gland, which produces a lot of hormones that regulate other organs and glands in the body. The brain stem, which is divided into the midbrain, the pons, and then the medulla oblongata, which is always fun to say. The cerebellum, which is kind of inferior and posterior to the cerebrum. Um, and the diencephalon, which includes the thalamus and the hypothalamus. Hypothalamus right there. Okay, so starting with the cerebral cortex, which is a thin outer layer that covers the cerebrum. Cortex of any organ is the outer layer. It is gray matter. It covers the cerebrum, or the cerebral hemispheres. It contains motor areas, sensory areas, and association areas. And you can see the different areas and what they control labeled here of the cerebral cortex. The frontal lobe, which is all of that, contains the primary motor area, the premotor area, Broca's area, which is for speech. There is another area for speech called, I think it's Wernicke's area, W-E-R, Wernicke's area. Anyway, these are both for speech, but if you have damage to Broca's area, you can't speak very well. You can understand language, but you can't speak very well. If you have damage to Wernicke's area, you can speak great, but it doesn't make any sense. I have watched recordings of people with damage to Wernicke's area, and it's like you're talking with them, but nothing that you say is making any sense to them, to you at all. Nothing that they say is making any sense to you at all. Um, you you could say, like for example, this one man that was being interviewed, they asked him, how long have you been a dentist? And he started talking about a football coming out of his mouth. And many of the things he talked about were dental related. They were related to the teeth and the body. But it wasn't an answer to the question he was being asked, you know. The parietal lobe, which is in here, contains somatosensory areas, and somatosensory means that sensations like that are going to affect the skeletal muscles. So touch, taste. In fact, the primary taste area is here. Your visual association area is in the occipital lobe, and your primary visual area. So occipital lobe is much of that is for vision. Your auditory area is in the temporal lobe, like you would think it would be. And then different areas for parts of the body, leg, trunk, arm, hand, face, and tongue, are kind of there in the frontal lobe where it meets the parietal lobes. The diencephalon is in the central region of the brain, and it consists of the hypothalamus and the thalamus. The hypothalamus controls the pituitary gland, so in effect, it controls the endocrine system. And the hypothalamus also contains our body's thermostat. Works just like a thermostat in your home. It receives the information of whether you're hot or cold, and then it adjusts your body temperature by telling your blood vessels and your muscles and your sweat glands, how to act. The thalamus is the gateway to and from the cortex. So it consists of gray matter, and it's the gateway to and from the outer layer of the cerebrum. And then the pineal gland is an interesting little gland. It secretes melatonin, and I think more people are aware of melatonin these days. Melatonin is the hormone that affects sleep, and actually it affects other things besides sleep, but it's thought to be because it affects sleep. So, for example, melatonin is thought to affect sexual function, which of course would be better if you got plenty of sleep. So, not completely well understood, but it's a hormone that is sold in pharmacies, and if you're having trouble sleeping, it's a natural sleep aid. All right, the cerebellum, which we looked at, that was the posterior inferior to the cerebrum, receives sensory input from the eyes, ears, joints, and muscles, and sends motor impulses to the skeletal muscle, but it mainly functions in balance and coordination. So the brain stem includes the midbrain, the pons, and the medulla oblongata. The midbrain is a relay station between the cerebrum and either the spinal cord or the cerebellum. The pons helps regulate breathing and head movements, and the medulla oblongata contains reflex centers for vomiting, coughing, sneezing, hiccuping, and swallowing. When you divide the peripheral nervous system into its components, so we already said that the nervous system is divided into the central nervous system and the peripheral nervous system. That the peripheral nervous system can be divided further into the somatic nervous system and the autonomic nervous system. And then the autonomic nervous system can be divided further into the parasympathetic and the sympathetic. That's kind of how it works. The somatic nervous system controls information that deals with skeletal muscle. It controls the skeletal muscle, and it receives information that is going to affect skeletal muscle activity. And the somatic nervous system is voluntary, conscious of its activity, and most of the activity is voluntary. The autonomic nervous system is involuntary, and it controls smooth muscles, cardiac muscles, and glands. That can be divided, the autonomic nervous system can be divided into the sympathetic and parasympathetic division. Okay, so I thought maybe the next slide talked about that, but the sympathetic nervous system will be active when you are in fight or flight response, when you are in a dangerous situation or a situation that makes you nervous. The parasympathetic division controls activities and causes activities to happen when you are more relaxed, when you're in more of a relaxed state. The cranial and spinal nerves are shown. Well, some of them are shown here, but the cranial nerves and the cranial nerves, of course, extend from the brain, and the spinal nerves extend from the spinal cord. Okay, here we go. I think that slide was in the wrong place. I apologize. But the autonomic nervous system, the sympathetic division is important in fight or flight responses. So it's going to accelerate your heartbeat, dilate your bronchi or your airways so that you can breathe faster. Blood is going to flow to your brain and to your muscles and be diverted away from your digestive and urinary systems. In the parasympathetic division, these are going to be responses associated with a relaxed state. So it's going to promote digestion and it's going to slow the heartbeat. And it's going to not dilate your bronchi, so you breathe slower. Some of the effects of the parasympathetic and the sympathetic division of the autonomic nervous system are shown here. Parasympathetic division, your pupils are constricted, whereas they are dilated in a fight or flight situation. Your tear glands are stimulated by the parasympathetic, but there's no effect by the sympathetic. More salivation when you're relaxed, not as much salivation. In fact, you may become dry-mouthed in a dangerous or fight or flight situation. Slows the heart rate in parasympathetic, speeds up the heart rate in sympathetic, constricts the bronchi, parasympathetic, and dilates the bronchi so you can breathe faster in sympathetic. The parasympathetic is going to stimulate digestion, whereas the sympathetic is going to inhibit digestion. And the parasympathetic will contract the bladder and stimulate erection, whereas the sympathetic will inhibit intestinal mobility, relax the bladder, and stimulate ejaculation. So drug abuse is when a person takes a drug at a dose level that increases the potential for a harmful effect. So you're abusing the drug. Addiction is when you need more of the drug to get the same effect, and withdrawal occurs when the user stops taking the drug. Most of us are familiar with these terms, even if we haven't used drugs or alcohol. Alcohol, drugs, and tobacco can all adversely affect a developing embryo, fetus, or newborn. This shows you the brain before cocaine use. The brain is less active, and how much more active the brain is after cocaine use, which is not necessarily a good thing. And neurodegenerative disorders, Alzheimer's and Parkinson's, it shows you a normal brain on the left, and then Alzheimer's disease brain on the right. It's neurodegeneration because the brain and the nervous system is degenerating. It's actually smaller, and you're losing nervous tissue. And Parkinson's is the disease where people will shake, and you can see that this man has a hunched over walk. So, and another thing to point out is that the damage to the neurons and the nervous tissue in these neurodegenerative disorders is not reversible. I mean, once the damage occurs, their neurons cannot regenerate, so it's irreversible. You can slow the progress, but you can't reverse it.